This video is a tutorial on how to take the name of compounds and determine the correct chemical formula, given that you have polyatomic ions as opposed to simple binary compounds of simple atomic ions. Many of the rules remain the same. Specifically, the need to have an overall neutral charge. The new piece of information is that you have things with "-ide suffixes or "-ate suffixes or various other suffixes for your negative ions that do not follow the strict rule of an atom with "-ide" being its negative ion. And because of that, there is a bit of memory work involved. So, in our first case, we have magnesium hydroxide. Magnesium forms the positive half, and because it is an element, you can look to the periodic chart and determine that it has a 2+ charge. Hydroxide is something that you must have memorized as OH-. These two atoms combined form the polyatomic ion hydroxide, and it will always appear as such with a negative charge. And so, because we have a -1 charge versus a +2 charge, we will need only one copy of the magnesium ion, and we'll need 2 copies of hydroxide. This is achieved by placing parentheses around the entire polyatomic ion and applying the subscript outside of the parentheses. In the case of calcium chloride, it's the same idea. Calcium has a 2+ charge. Chlorite is a part of the chlorate oxyanion family, and as such has a formula ClO2 with a -1 charge. This gives us the chemical formula. Ca for our calcium, ClO2 is in parentheses, and a subscript of 2 goes on the outside of those parentheses to indicate that we need 2 copies of that polyatomic ion. Barium phosphate. Barium is Ba, 2+. The phosphate ion is PO4, 3-. So we will need 3 copies of the barium and 2 copies of the phosphate. So a subscript of 3 on our barium, parentheses around the entire phosphate ion, and a subscript of 2. Mercury 1 is a polyatomic ion, and it appears as Hg2 with a 2+ charge. Fluoride is the negative ion of fluorine, and so we will need 2 copies of the fluoride ion. So our formula then is Hg2F2. Ammonium sulfide. Ammonium is a polyatomic ion with the formula NH4 +1 charge. Sulfide is the negative ion of the sulfur atom. And just as we did before, to get multiple copies, which we'll need for the ammonium, we write our polyatomic ion inside parentheses with a subscript. And finally, hydrogen peroxide. Because hydrogen comes first and keeps its name, it is the positive ion. Peroxide is the negative ion, and it has the formula O2, 2-. And so having a neutral compound requires 2 copies of the hydrogen ion, so H2O2. And so with these 6 examples, it is possible to see that it is necessary to be able to recall from memory the identities of your polyatomic ions, recognizing them by name in the compound, and then following the standard rules of forming these compounds as found when we are just using regular old atoms.